Hello everybody, welcome all of you from my course Computer Networks. I am Professor Dr. A.K.M. Head, Department of Electronics and Telecommunication Engineering, Daffodil International University. This session I am going to talk about IP version 6 introductions. In these chapters we will have brief description about IP version 6, and as you know, the IP version 6 is the extended version of IP version 4, and we will have a lot of description about this. What is the functionality, what is the salient features of IP version 6, why IP version 6, how can we make subnets, everything details we will be discussing here. So, we can see in this figure the internet access. You can see the internet protocol. We can use here addresses, number of addresses, and we can how to connect these addresses to the internet. We can see in this figure. Okay, if we say why do you need IP version 6, or what's the introduction of IP version 6? Actually, IP version 6 is the most recent version of the internet protocol, the communications protocol that provides an identification and location system for computers on networks and routes traffic across the internet. You can see in this figure here the IP version address is in hexadecimal, and it is situated here, and there are the address is from left to right side, and it is 128 bits. And here you can see also in this figure the zeros can be omitted, and how the all values from the hex state can be defined in the binary format in the below part of this figure. And we'll have the description details, what is the basic structure of IP version 6 and how it is calculated. Why IP version 6? Earlier before I said is the extended version of IP version 4, and actually it is needed due to the point of deficiency of IP version 4, address space exhaustion, now new types of service integration, multicast, quality of service, security is a very main concern, because it was needed to implement some security in IP version 6. So that's why it is really implemented. We'll see. Mobility and header and format limitations. Okay, we can see the IP version 6 address examples in this slide. You can see here, we know, as earlier I said, IP version 6 address is 128 bits long, and the total number of addresses 2 to the power 128. The figure is 340, etc. Very big figure in this here. You can see the very big long figure here. The very interesting thing is, you know, if we could use the IP version 4 here, but the rapid growing up internet of the total modern world, so it is very difficult to accommodate using IP addresses for all workstations through IP version 4. That's why it was needed to extend this IP version 4. Now it is said that it is proverb like this: if the computers or workstations are situated in just one atom distance from so far, I think every atom these devices could be accommodated using more than millions IP addresses. So I think it will be never be happen, because at least there will be existence for workstations. So this is a very initiative and good inventions of modern world, this IP version 6. And in hex 4 bits, also called nibble, is represented by a hex digit. So 128 bits, it reduced down to 32 hex digits, and you can see in this figure here the values, how it is defined in nibbles, and the 4 hexes to 4 bits, it is defined for each hexadecimal values using these 4 bits in binary format. IP address addressing examples you can see from the router. The figure here, this router has the Ethernet part, and in the local area network, we can see the figure and interface Ethernet we can see, and show IP version 6 interface using this command. We can see the situations. You can also see how MAC address is also incorporated in these addressing examples. Binary conversion, this is very easy, but you have to determine, you have to understand, because this is very sensitive. If any bits mismatch from this configuration, so whole system or whole IP addressing techniques will be wrong. So you can hear the decimal and right side the binary values and the hexadecimal values. And if you see in the left side the zeros here, how it is defined in the 4 bits binary, and it is the what's the equal value of hexadecimal. Suppose as for example in decimal value is 1, we are writing here 0001 in binary format, and in hexadecimal we are saying is 1. On the other hand, in the binary values, in the decimal values is 10, and we are saying 1010 in binary formats, and in the hexadecimal we are saying this is value is A. So in this constitution from 0 to F, you can find out the value of hexadecimals in form here. IP version 6 addressing structure here, this is very important. You can see from left to right, the 0 to 32 bits is defined for ISP, Internet Service Provider, and for 16 bits up to the if you add the 16 bits from 32, it is now at 48 bits, and this is the customer side. And from 48 to, and again the 16 bits, this is for subnet, and this is for subnetting, and rest of the 64 bit assigned for host address for devices. And you can see the right side is /128. And this bytes means 8 bits here, and nibble 4 bits, and hex state 16 bits it is defined. IP address structure. If you see from this line, from this here, the underline marks here, there are some parts here defined: global routing prefix, subnet ID, and right side the interface ID. The site prefix or global routing prefix is the first, third hexes or 48 bits of the addresses, as I discussed earlier. It is assigned by the service provider, because this values is fixed for the service provider. They will maintain this part. The site topology or subnet ID is the fourth hexes of the address. You can see the 5270 from the subnet ID. It is actually fixed for the subnet ID, and the interface ID is the last 4 hexes or 64 bits of the addresses, and it can be manually or dynamically assigned using the EUI64 common, the extended unique identifier. This very, and finally the IP address is /64. That means the 64 bits are in the network part. IP address structure here also, you can see the first 3 bits at fixed at, you can see it 001 or 200. We have to mention these 3 bits in the, and it is double clone /12. And bit 16 to 24 identifies the regional registry, and it is AFRENIC, FNIC, LACNIC, RIP, and NCC and AFRIN. And you can see also there are some formats it is given in Belo. Okay, so IP version 6 structure, we can continue for this part. What's the remaining bits? Suppose here it is red mark, it is defined here for ISP. You can see here remaining 8 bits up to /32 identifies the ISP. The third hexes to represent the site customer identifier, and this is, you can see also red marks 0001, you can see from this figure. And the fourth hexes represent the site topology or subnet ID, and it allows 65536. That means you can say 65,536 subnets with huge large number of it is actually 18 quadrillion for a subnet, a huge number of usable hosts you can find out here. No third of the host address field here, and it is also defined in the red mark here. Okay, so IP address scheme and subnets. If we discuss here, we can say this is the very important part, this interface ID. The interface ID, or the remaining 64 bits of the address, can be manually configured or dynamically by using the UI64 extended unique identifier. You can see the UI64 commands uses the device 40 bits MAC addresses. As you know, the MAC address contains 48 bits and it is also defined hexadecimal, and this the 24 bits, that means first 24 bits is provided or maintained by IEEE, and last 24 bits for vendor identifications. And the first network and last broadcast address may be assigned to an interface. An interface may contain more than one IP address. There are no broadcast addresses, multicast is used instead. So scheme and subnets continuations, IP version 6 use the same method as IP version 4 to subnet the classes. You can see their CIDR notation also. The 1/127, that means the true gives you the true addresses. That means you have the 1 bits and there are 2 combinations. And /124 gives you 16 addresses. It means the network portion, the 124 bits, and the remaining you have 4 bits. So 2 to the power 4 is 16 addresses here, and /123 gives you 256 addresses consequently. So it is recommended to simplify and design purposes to use /64 everywhere. Using anything less than this /63 could potentially break IP version 6 features and cause increased design complexity, we can see from here. Okay, so you can see the leading zeros in this figure and double colons. This is very important for addressing here. So that means leading zeros in any 60 selections can be omitted. So that means you have before or after addresses omissions. Okay, so you can see one addresses here 2001 0D DB8 here in the /64 IP addresses. You can see here address after omission. If you see how it is addresses after omissions, that you can see the leading zeros have been omitted from here. Instead of 0D B8 we are writing here DB8, and also 152 7 zeros, you can 5 to 7 zeros, you can say when it is rewritten, but zeros is not omitted because the trailing zeros we are not considering here. So the rule applies only to leading zeros. If trailing zeros are omitted, the addresses would be vague. So we can't consider any red mark here. It is very clearly, it is defined here from the trailing zeros. It is not possible to omit from the IP addresses. Leading zeros are the continuations here. You can see the double colons or compressing zeros can be used to shorten an IP version 6 addresses when one or more hexes consist of all zeros here. So look here, 116, there are some octets of the IP version 6 is given here, and how the double clone can be presented in the IP version 6 format, for rewritten format or updated format or revision format. The double clones can only be used to compress a single contiguous 16 bits blocks. You cannot use double clones to include part of a block. Double clones can only be used once in an address. If it's used more than once, the address could be ambiguous. So from this figure here, these addresses can be, there are some possibilities this last addresses here from the 4 parts here. There are some possibilities, but we should understand what is the legal definition from here. Okay, so that means in ourselves, if we define, it should not be possible. There are some rules and regulations. There is some syntax. Based on this syntax, we have to use double clones, and of course it must be assigned in 1 times. If it is used more than once, the addresses could be ambiguous. IP addresses, you can see the IP version 6 here, one IP version 6 addresses is given here, and what is the binary conversion of these IP version 6 addresses. Subnetting in IP version 6, because we as earlier said, the network portion we have here 64 bits and host portion 64 bits, and the ISP provides the 48 bits, and we have subnets for only 16 bits here, and interface identifier for 68 bits, and 65,535 subnets per slash 48 addresses. And IP addresses types here is very important in this figure. Here you can see there are some per fields here, IP version 6 address types, IP version 6 notifications, and IP version 4 you can compare here, and you can give some values here, unspecified double clone slash 28, and it is, if you define in IP versions 4, it is 0.0.0.0, and it is loopback interface double clone 1, and for IP version 4 you can see here 127.0.0.1. Global unicast 2000 double clone slash 3, no equivalent single block for IP version 4. Unique local addresses FC000 double clone slash 7, and you can write in the 10.000 slash 8, 172.16.000 slash 12, 192.168.0.0 slash 16. Link local address is very important here. For IP version 6 you can define here FE80 double clone 200 clone 5A double E clone FE double A clone 20A2, and consequently we have multicast 6 to 4 IP version 4 mapped, and documentation also we can be accommodated in IP version 6 and IP version 4. Well, in this slide we are going to talk about some casting here. IP version 6 addresses types is unicast addresses, and if we define unicast addresses and what is the functionalities of this, uniquely identify a single interface on an IP version 6 devices. A packet sent to unicast addresses destination travels from one host to the destination host. That means we have the many of users here. If one workstation sends the information, if it is targeted for another computers or host, so that means among many of hosts one is targeted, so the communication is point to point or not like this, it is actually unicast. And multicast also, the sum of the persons have been communicated among many of things, and broadcast means all of the users have been communicated from some person or from some other users from here. An interface may have more than one IP address, IP version 6 address of course, or an IP version 6 and IP version 4 addresses, which is referred to a double stack, and it is preferable. That means the IP version 6 provide this facilitation. That means it is the very speciality of IP version 6. When mistakes are made on entering an address to the IP version 6 interface, the user must issue no IP version 6 address command before entering the correct one, or the address will remain on the interface. And the same for IP version 4 also. If we make some mistakes for IP version 4, if we want to remove this command no IP version 4 from the CLI command, you can use also, as well as for same thing for IP version 6 addresses also. IP version 6 address types, as I also say, the multicast means all multicast addresses are identified by their reserved addresses range FE00 double clone 0/8. A packet sent to the multicast address is delivered to all devices that are identified by the addresses. That means some of the addresses will be identified and the sum of special host or some special workstations will be identified by the administrator and packet will be sent. Those are identified. A multicast addresses identifies a group of interfaces. IP addresses types, the continuation of this slide, any cast address also can be viewed here. Any cast, to any cast address can be assigned to several interfaces devices. A packet sent to any cast addresses goes only to the nearest number of the groups according to the routing protocol measures of distance. Any cast is described as a cross between anycast and multicast. The difference between an anycast and multicast is that in anycast packet is only delivered to a single device while multicast send it to multiple devices. This actually, as we discussed earlier before about the functional differences between unicast and multicast. IP addresses types continuation here, link local addresses. The link local addresses are designed for use on a single local link. Link local addresses are automatically configured on all interfaces. In the same, there are also some prefix notation also, and do not forward packet with the destination and source address containing local link address. And loopback addresses, similar function to IP version 4 as I earlier said, it is defined in 127.0.0.0 addresses, and the local loop addresses 0, clone 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 1, or maybe simplify by using double clones as double clone 1. It is used by a device to send a packet to itself. As I earlier said, the loopback interface, it gives the information itself is a TCP/IP connectivity. That means whether the LAN setup is available or not. If we make this ping command using this, so from our NIC card automatically one response will come, reply from. That means yes, local area network is available for my computer. Okay, in this slide we can discuss about link local addresses, the stateless address configuration SAAAC, mod UI64 privacy, global unicast, DHCP and SAAAC modified UI64 and privacy. Modified UI64 and UI64, you can see from this figure also there is some information. IP version 6 configuration verify, you can see there automatically configuration here. We can obtain an IP address automatically and use the also manually we can configure the IP version 6 addresses. And you can see the right side from the IP version 6 address to 001, DB8 and some other values, and subnet prefix length is 64 here, and also you can find out, we can put here the default gateway as well as. IP version 6 configurations, Windows IP configuration, the adapter Bluetooth network configuration. If you write the command users BA and IP config, and you can see the connection is specific DNS suffix, IP addresses, version 6 address, link local IP version 6 address, IP version 4 address, subnet mask, default gateway as well as here. And IP version 6 ISP addressing, you can see every ISP receives a /32 or more these versions, and providing 65,536 site addresses /48, and you can see the here internet here, and from the internet side there are /32 ISP addresses from these configurations. And IP version 6 site addressing here as well as every site that receives a /48, providing 65,536 /64 local area network addresses, and you can see the figure. This is from the ISP configurations. The router receives the informations /48, and workstations host are configured manually or using DHCP protocols as well as. IP version 6 also, every LAN segment receives a /64 addresses, provide 264 interface addresses for local area network, and also from this figure we can have some brief description how configure local area network addresses in IP version 6 format. IP version 6 device and addressing, every device interface receives a /128 addresses and may be delivered from IP addresses MAC addresses. a random number auto configuration or manual configurations. Also you can see from the routers here 1/128, and it is classified into some workstations as well as. IP version 6 address space here. These are /0/3 IANA reserve global unicast, and also the RIR IP addresses configurations also illustrated in this figure, and you can see from details from these references. IP addresses space and IP version 6 prefix allocation RFC. I can see some example here. Suppose as 0000 clone double clone /8 reserve file IETF, and 2000 double clone /3 global unicast, as well as last 2002 double clone /16 624 RFC 3056 as well as. So this table you can see from this very briefly here. Header configuration, IP version 6 header, IP version 6 header, as I earlier compared. Before that there is some comparisons from here, the first version as well as the version also, the IHL type of service, total length identifications for IP version 4 header. Consequently in the IP version 6 header, there are version, traffic class, flow control, payload length, next header, hop count, source addresses and destination addresses. And this IP version 6 transition, as well as you can see there are some form and inform, there are IP version 6 as well as IP version 4 can be used here. Some native tunneling and dual stacks, there is some provision of this IP version 6. The dual stack configuration, you can see this from the router in this figure, the IP version 4 192.168.99.1 in the interface, and also in the same interface you can mention 2001, that means clone TV8 clone 213 clone 1 double clone 1/64, that means dual stack can be provisioned here, and IP version 6 in our router, and also telnet ping, trace route, SS, DNS client, TFTP also can be accommodated here. Tunneling encapsulation, decapsulations, you can see from this figure, IP version 6 host, IP version 6 network, dual stack router, IP version 4 network configurations, and also some other facilities from these tunneling encapsulations and decapsulations. IP version 6, it can be used with many routing protocols, IG interrogator routing protocol, routing information protocol, Cisco EIGRP enhanced interrogator routing protocol, OSPF open short first, and also BGP MP, some Cisco IOS supported all of them this IP version 6. And if we compare between IP version 6 and IP version 4, you can see there are some comparison parameters here, 128-bit address containing 132-bit addresses, hexadecimal format, use binary format from between 0 to 1. MTT, maximum transmission time, you can say 1280 bytes, and for IP version 4 it is 576 bytes. Network address and broadcast addresses can be assigned. Also network address and broadcast address cannot be assigned to accordingly in the interface in the IP version 4. Native IP6 encryption, VPN technologies must be used to encrypt IP versions of packets. So these are the main concern. If you compare with IP version 6 and IP version 4, then you can find out these parameters from this here. So thank you very much from these sessions. So we'll have next sessions, we'll be discussing another chapter. Thank you very much.